In this video I will discuss when the magnetic force becomes zero. I will start with the definition for the magnetic force. This is the magnetic force that object 1 exerts on object 2. And to find this, I need to know what is the charge. This will be Q2. The force is acting on Q2 times the velocity 2 of charge 2. And then I also need the magnetic field that object 1 creates at the location of object 2. So, let's see, I can give you an idea. If this is a wire and this is object 1, it creates the current here. Let's say I have a current that goes to the right. This current that's flowing in the wire will create a magnetic field everywhere around it. Now, if I have a charge, say I have an electron here and it's moving this way, this will be V2, this will be Q2, this electron will be Q2, the velocity of this charge will be V2, and then 1 would be the current that's flowing in the wire. This will create the magnetic field at the location of the electron, and then that magnetic field will exert the force on the charge. All right, now this is the theory, and this will give me a vector. Okay, this is a vector. How do I know that? The velocity v is a vector, the magnetic field B is a vector, the cross product between the two is a vector, and when I multiply a vector with a number, I will get a vector. Now, there are times where the only thing that I'm interested in is to know the magnitude of the magnetic force. And to find the magnitude, I need to take simply the absolute value of the charge Q2 and then the magnitude of the cross product. If you review the material for the magnitude of cross products mathematically, okay, there is not much physics here, I'm just gonna take the magnitude of the cross product between two vectors, and this will be the magnitude of the first vector times the magnitude of the second vector times the absolute value of the sine of theta. Now, what is theta? Theta is the angle between the first vector and the second vector. So if this is B and this is V, this is the angle theta, the angle between the two vectors. Now, if I want to find out when this is 0, then I have to make the left term, the left side 0. Of course, if you do not have a charge, if there is no charge, of course there is no magnetic force. So that's one way to make the magnetic force 0, but this is trivial. Okay, I'm not looking for the cases where I don't have any charge. If the velocity, if the speed of the charge is 0, then the magnetic force is 0. So that's one possibility. If V2 is 0, then there is no magnetic force acting. That's the first case, which means if your charge here is not moving, then you have no magnetic force acting on it. If there is no magnetic field at that location, then of course there is no magnetic force. That is also trivial. I'm not going to make notes about that. And the other case is if the sine of if this is 0, then again, then the magnetic force will be 0. Now, for the sine of theta to be 0, the way that I can make that happen is if the angle is theta or pi. Now, what does that mean? If your velocity, if V2 points to the right and the magnetic field points in the same direction, then the angle is 0. Or the other option, if the angle theta is pi, if the charge is moving to the right and the magnetic field points to the left. Here the angle is pi. Here the angle between the two vectors is 0. So these are the few cases that allow you to make the magnetic force 0. And I do recommend, before you do these calculations, if you happen to encounter a case where B and V point in the same direction, don't move on. Don't do any calculations here. Just look at the angle between those two vectors. If the angle is 0 or pi, just stop there and say, because the magnitude, because sine theta will give you a 0, the magnetic force is 0, and therefore you don't have to do any calculations.